Michelle. Welcome to Math Your Way. Okay, so today we're going to be discussing finding the domain of a function. The first type of function we're going to be talking about is a linear equation. The domain is all possible values of x. The linear equation is the easiest because all possible values of x when you have a linear equation is all real numbers, which will be annotated as negative infinity to infinity. The next equation that we'll be working with is a rational function. A rational function is just a function that is in fraction form. We have 2 equals 5 divided by x minus 1. We all know that if this denominator equals 0, then our function will be undefined. So therefore, we do not want to use a number that will make it equal to 0. So the first step will be to set your problem equal to 0 that involves the x. X minus 1 equals 0. We're solving, so x equals 1. So wherever x equals 1, we're going to get 0. So therefore, we do not want to put a 1 because 1 minus 1 is 0, and that will make our function undefined. Therefore, when we want to know all possible values of x, we want to not include the number 1. So if we drew this on a number line, it would be annotated as an open circle because we don't want to include it, but numbers shaded this way and all the numbers shaded this way. So when we want to annotate it in our interval notation, we will say negative infinity to 1. We're not going to include it because it's an open circle with the union of 1 to infinity. And that's how you will write for the rational functions. Wherever you see an x, you'll solve and make sure that your fraction does not equal 0 in the denominator, because once again, that will make the function undefined. So therefore, we did not include 1 because 1 minus 1 gives us 0, and we use our interval notation in this manner. Last but not least is a square root or a radical function, or a function that involves a radical. And right here we have a function that involves a radical. Now, the only ones we have to worry about with radicals is if the number or the index is an even. Like if this is an imaginary 2 right here, and then if it was a 4, 6, or whatever, even number, then we will follow this rule. So the rule with radical roots of even radicals, you cannot have a negative number. So if this is a negative, you cannot take the square root of a negative number because it will be imaginary. So what we like to do is say, set up our radical function, the x, because we're still looking for all possible values of x. We like to say it has to be greater than or equal to 0. Because anything less than 0 will make this a negative number, and therefore you cannot take the radical of a negative number because it will be imaginary. So we know that our x has to be greater than or equal to 0. So when we're looking at this on the number line, this is 0. 0 can be included because 0, you can take the square root of 0. We shade this way. So therefore, because this is a closed circle, our bracket is now a bracket instead of parentheses. For our interval notation, we do 0, comma, infinity. So let me do some examples with you all, just to ensure that you understand. All right, so now I want you to try these 3 problems on your own. Push pause. Once you're done completing the problems, go ahead and push play, and I will go over each one. So let me just say, the first thing you want to do when you're solving these problems now that you know it's 3 categories, linear, rational, and square root, you have to ask yourself, okay, what am I looking at first? Okay, is it a linear function? Is it a rational function? Or is it a square root? All right, now that you're back, let's solve the first one. The first one is a linear function, and let me tell you why. The x is x on the top, and it can also be written as 1/3 x minus 7, because we know 1/3 times x over 1 is just x over 3. It's the same thing. So if you were having trouble with that, this is not a rational function. It is a linear function. And therefore, with linear functions and the x being in the numerator, the x in the numerator can be any number. We will say that the interval notation is negative infinity to infinity. All right? This one is a rational function. The denominator has the x now, and therefore we know that the denominator cannot equal 0, so I'm going to set it up to 0 to find out what my x is that's going to make it 0. Some people can look at it and tell 2 minus 2 will give me 0, but for some people who can't, we'll solve for x. Negative x equals negative 2, so positive x has to equal 2. Therefore, we do not want x equal 2, because we know that 2 minus 2 is going to give me 0. And therefore, when I'm doing my number line, we're going to do an open bracket, an open circle, and we can shade both sides. So my interval notation will be negative infinity to 2. We do not want to include 2 because 2 will make that 0, with the union of 2 to infinity. All right? So this is my interval notation for my domain. This is my interval notation for that domain. And this is a radical function. We know that with radical functions, especially when it has a positive, and we know that that's imaginary 2, a positive, or an even number that's imaginary 2, we cannot have a negative number. So therefore, we have to say that everything under the radical have to be greater than 0. So when we add our 1, x has to be greater than or equal to 1. So when we do our interval notation, we can do our number line, and we can shade in the number 1, and it can be all numbers greater than. So we're going to shade this way. Sorry. So all numbers greater than 1, including 1. So our interval notation will include 1. So I'm going to do a bracket. That's a bracket, guys. 1, comma, infinity. And that will be our interval notation for that problem. So please, if you have any questions or anything, go ahead and shoot me an email at mathyourwayva@gmail.com. Please like, subscribe, and share this video. Thank you, and have a good day.